Have you ever wondered what it would mean for AI to think like a human? Not just follow instructions, but imagine, plan, and reason autonomously. This isn't science fiction. It's the focus of groundbreaking research by Slimane Larabi, who's exploring how mental imagery, the vivid internal pictures we create in our minds, could revolutionize artificial intelligence. Let's break down how this could bridge the gap between machine logic and human-like cognition. Current AI systems are like highly skilled assistants. They process data, answer queries, and execute tasks, but they lack the ability to simulate scenarios, connect abstract ideas, or adapt to novel situations without explicit programming. They're brilliant at pattern recognition, but they don't think independently. What if we could teach machines to imagine? Mental imagery is the brain's way of creating internal simulations. When you visualize solving a math problem or planning a trip, your mind generates mental movies that test possibilities, refine strategies, and predict outcomes. Larabi's research asks, what if AI could do the same? By embedding this capability, we're not just improving efficiency, we're unlocking a new frontier in machine intelligence. The answer lies in a framework called the Cognitive Thinking Unit, CTU, which mimics the brain's reasoning process. Let's dissect its four core components. 1. Needs unit. This acts as a machine's to-do list, tracking goals, tasks, or problems to solve. 2. Input data unit. It processes sensory information, images, text, or environmental data to build a contextual understanding. 3. Mental imagery unit, the heart of the system. It generates internal simulations, like a mental movie of possible scenarios, using models like Stable Diffusion to translate abstract concepts into visual or conceptual representations. 4. Cognitive Thinking Unit, CTU, the decision-making engine. It synthesizes needs, data, and imagery to reason, plan, and generate responses. Imagine an AI tasked with navigating a room. The input data unit processes visual cues, the needs unit identifies the goal, reach the door, and the mental imagery unit creates a mental map of potential paths. The CTU then evaluates these scenarios, selecting the optimal route without explicit instructions. This isn't just following rules, it's simulating possibilities, much like a human would. But how does this translate to real-world applications? Let's simplify. The system doesn't just process data, it generates scenarios. For example, if asked, how do I open the door? It might produce a storyboard, a hand picking up keys, a person approaching the door, and the door creaking open. These aren't photorealistic images, but abstract sketches that capture the essence of the action. The implications are profound. Traditional AI struggles with ambiguity, creativity, and real-world adaptability. By embedding mental imagery, we're giving machines a tool to bridge this gap. Imagine AI that can troubleshoot problems by simulating solutions, generate novel ideas by exploring hypotheticals, or even empathize by visualizing perspectives. This isn't just smarter AI. It's a step toward machines that think with the same spark of imagination that defines human cognition. How does this work technically? The CTU uses a two-step process. 1. Context matching. It aligns user goals with environmental descriptions. For instance, if the task is find a laptop with keys, the system identifies relevant objects in a cluttered scene. 2. Mental sketch generation. Using diffusion models, it translates action sequences, like grab keys, walk to the door, open it, into stylized visualizations. These sketches aren't precise, but convey the core logic of the plan. Consider a scenario where an AI is told, I need the keys to open the door. Instead of a literal response, it generates a mental image of keys, a door, and the act of unlocking. If the key fails, the CTU simulates alternatives, breaking the door, calling for help, or checking the key's validity. This iterative process mirrors human problem-solving, where intuition and imagination guide decisions. This research isn't just theoretical. For individuals with disabilities, it could enable thought-to-action interfaces. For creatives, it might spark new ideas by visualizing hypotheticals. And for AI, it's a leap toward autonomous reasoning, where machines don't just process data but imagine possibilities. Of course, this is still early research, but it's already reshaping how we think about AI. By mimicking the brain's ability to visualize, we're not just building smarter machines, we're unlocking new ways for humans and AI to collaborate. What might we create when imagination meets computation? The future is waiting to be visualized. Thanks for watching. If you're curious about how AI is evolving, hit subscribe for more deep dives into the science of tomorrow. And let me know in the comments, what kind of thinking would you want from your AI? Let's keep exploring the future of smart machines together.